So one of the things that I wanted to talk to you about here in the forest is that most of our forests, probably up into, close to the Churchill River, have all been mapped by the provincial and federal soil survey groups over the years. And so there are these maps that are available for a lot of different regions, forest regions of the province, and they're really helpful in terms of understanding on a big picture what you might find for soil classification. And so this is the map from Prince Albert map sheet, and we are in the Nesbitt Provincial Forest, and you can see that all these colored areas are forested areas, and the other stuff that is kind of white here would represent agricultural land. The Weyerhaeuser Mill is here, and we are actually in this yellow region here, and the soil association for this particular polygon is Nesbitt 3. And if you look at Nesbitt 3, there's a legend here. This is a Nesbitt soil, and these actually fall under dark gray Chernozemic soils, which is really interesting because we don't find a lot of Chernozemic soils under forest vegetation. And so this is kind of a unique spot, the southern end of the boreal forest, and we'll see actually what the pit says if it does in fact match what we're seeing here for this classification. There also another polygon closely related to this is the Pine Association, which is probably what we saw at the top of the hill, which contains those Brunosols and Regosols. But it's really important that if you have a chance to going out to an area and you haven't been there before, grab a soils map, have a look at it, and get a broad idea or a big picture idea of what you might find there in terms of soils. This is the map sheet. We're in this Nesbitt Provincial Forest here, and we are located somewhere in this polygon here, which says NT3, which is the Nesbitt Soil Association, and then the secondary association is Pine 2. So we have this mixture of these Chernozemic soils and these Brunosolic soils, Regosolic soils in this particular polygon. And the question is, what are we going to find in our particular soil pit? So we're down here, the pit at the bottom of the slope, and as you can see, there's a lot more vegetation around here, but there are also some differences in this pit compared to the pit at the top of the slope. If we want to identify this profile, we got to figure out what horizons are here. And so having a look at this, what do you all see? I see some things in terms of a really dark color here in the surface, a lightish brownish color below that, and then down even deeper it even gets lighter in color. And so I think we have some very distinct horizons that have occurred here. The question is, how do we delineate these? And so if I was to draw these or mark these, I would do something like this for the profile, and I would call this an AH horizon. This reddish color underneath all the way down to probably about here, which is about 45-50 centimeters, would be a B horizon, but a BM because it's reddish in color. And then below that horizon, I believe would be a C, because there isn't really any coloration to it. It's kind of the same color, and it hasn't been impacted at all by penegetic processes. The interesting thing below the C horizon, though, at about 80 centimeters, is that the texture changes. And just to give you a little bit of an idea of that, you can see here, here's the AH, the BM horizon, the C, and then now we're working with more coarser material, even some rocks now. And so at the bottom of the pit, there's certainly a change in texture from those horizons above. And we'll talk in a few minutes about the texture of each of these different horizons. So we have an AH, a BM, a C. The question is now, what is this profile classified as? And if we were dealing with just this part of the pit here, we have an AH is greater than 10 centimeters. And when we go through the key that we have, we get to what we call a Chernozemic A horizon, which is an AH that is greater than 10 centimeters thick. And so then what is the great group and the subgroup? And going through the key that I have here, the great group, we have to do the color. And so we'll do that in a minute. I'll get the color book out and we'll actually see what the dry color is for this and how it might match. And then the subgroup is, because it has a BM horizon greater than 5 centimeter thick, this is going to be an orthic. And so we just don't know if this is a dark gray or a black or even a dark brown Chernozem. And that's what we have to do the color for, to figure that out. So the other question would be, there could be, 5 of us sitting around this pit and thinking about, what is this really a Chernism or is this something else? And if you were to go to the other side of this pit, you would see that we probably don't have quite 10 centimeters of an AH horizon. And so what would this bump this profile into? And if we look at our keys, this actually would then end up being a Brunosolic soil because of the BM horizon. There's no BT, and when you look at the sequence of orders in terms of figuring out your soil orders, the next one would be Brunosolic soil. And so, one could argue, is this a Chernism? Is this a Brunosol? And depending on where you put your do your soil classification, that could have an impact on how you define this particular pit. But there is really a nice AH horizon around this pit, and so I would think that this would be more a Chernism, which would also align with the soil map that we were looking at for the dark gray Chernisms that are mapped in this area, so it would match up with that as well. Okay, to do the color, you have to dry the soil. You can see here's an example of wet soil that just came out of the pit. And usually what I do is I take the soil, put it in the palm of my hand, and I just start rubbing it around to dry it. And for me, that's the simplest way to dry this material for doing soil color. In order to figure out what grade group this is, we need to do the color on a dry soil sample. And so here is a Munsell color chart 10YR, and there's a good video by Dr. Pennick on how to use the Munsell color chart. So I'm going to take this color chart, I've dried the soil in my hand, and I'm going to put it on here, and it looks to be very much close to a value of 2, which is on this scale, and the chroma here of about, well, even close to 1 or 1.5. And so if we look at the chart, it says if color value is less than 3.5 and a chroma of less than 1.5, this would be a black grade group. And I know the soil classification said that this would be a dark gray, but I mean the color right here would indicate that this could be a black Chernism, and more than likely with a BM horizon, this would be an orthic black Chernism at this particular site. So the texture for this particular pit, I've got the 4 different horizons that we talked about when we were classifying the soil. Again, our AH horizon, our BM horizon, our C1 horizon, and then our C2 horizon, which is really a change in texture when you start getting these larger coarse fragments in it. So the question is, what is the texture for all these different things? And so when I take some of this AH horizon, I can actually create a little bit of a flaking with it. And so I think in looking at the texture in this, or a weak cast, I guess, is what I'm really seeing here, is that this would be a loamy sand in the AH horizon. And I've dried it here and looked at it. So it's more a loamy sand. The BM horizon here, this is it dried. And you can see, again, this looks like a fine sand. Getting down to the C1 horizon, again, when I dried it, looks like a fine sand. And then getting into this C2 horizon with a lot more coarse fragments in it, I would classify this more as a coarse textured material. So loamy sand, fine sand, and a coarse sand going down through the profile. And as you can imagine, these changes in texture will have an impact on how water is flowing through this soil profile. We have to talk about the parent material for this particular site, and with the upper slope and down to this lower slope, but we are sandwiched here right next to the North Saskatchewan River. So you can imagine when we think about different kinds of parent materials, whether it's lacustrine or fluvial or tills, what we're seeing here in the surface is a lot of fine sandy material. And with our proximity to the river, then we would classify this as probably glacial fluvial type deposits. And you can see that even on the bottom here in this C2 horizon, we've got these rounded stones, which indicates it's being water worked, probably a different intensity of water to carry this material, but again, glacial fluvial. So this profile and the profile at the top of the hill would have a kind of glacial fluvial parent material. And again, this really coincides with what we see with this river. and next to us, and being probably the glacial meltwater stream from the glacier itself, depositing much of this material, and some of it may have even been water worked at one time or another as well. Using the Ontario Guide for Drainage Classes, when we look at the textures that we talked about, being a loamy sand and then fine sands and a coarse sand, if we go through the chart in the book looking at drainage classes, again we come down to, is this very rapid or is this rapid? And in the surface, probably upper 80 centimeters, we don't have any coarse fragments or 35% of the volume of particles greater than 2 millimeters. So we go down to the next one, and we have fine sand and medium sand. And so because of that, the textures that we have, this would actually then be classified as a rapid drainage class, which is what we saw at the top of the hill. So the drainage class hasn't changed based on the textures for either of these two sites, but it gives you an idea that water will flow through these soils very quickly, and not a lot is stored here, which impacts the amount of vegetation. I think the important thing is that we have this really nice AH horizon, which has a lot of organic matter in it, and because of that, we're seeing a lot more understory vegetation here with mosses and a lot of different kinds of herbs. Wild lily of the valley and kinnicknick. There's even some blueberry around here, so quite a diversity in terms of different plant species, but a lot of that has to do with moisture, and I believe this nice AH horizon, which has a lot of organic matter, which can hold also a little bit of water in it as well. Also classifying the soil, we need to talk about the forest floor, and up at the top of the hill we said that was a more humus form. Down here it's a little bit different because we have this AH horizon, and if you look, there is a little bit of litter on the top, but after that you're right into the AH horizon. And so because of that, this probably then would classify out as a mull humus form. And again, there are three general broad groupings: the moor, which has this distinct boundary with the mineral soil; a motor, which is in between a mull and a moor; and then this mull humus form, which is really this results in this AH horizon. So a different kind of forest floor here, and something you don't see very often in our boreal forests. For the most part, you'll end up seeing a lot of moors, but again, this forest floor is tied in very closely with this AH horizon in this particular profile.